right, let's take a look at our curriculum this week. Since we are starting something new, this is kind of a cool thing. Hope you enjoy this. We're gonna look at matrices. Yes, a matrices matrix. It's like, maybe this is the first time you've seen a matrix. We'll see. So, all right, let's look at it. Our grade screen as usual. So, look at our grade screen. Look, we are done with Module 5. So, you should have all of the Module 5 stuff done. You should have turned the test in by Sunday night. And hopefully you've got all done. If you don't, get it done soon. Don't wait till you forget it all, because it's logarithms and exponential, right? We don't play with that a whole lot. So you don't want to wait 3 weeks till you forget everything and then go back and try to do that test. No, get it done. Get all the lessons done and then turn in the tests. So if you're missing lessons, do those first. But as you look at what we have coming up here, this looks a little different. Whoa, what's all this Module 5.5? Yeah, I've added this in between Module 5 and 6. This is the first year we've added matrices to Algebra 2. So I said, I'm going to put it right here and have a Module 5.5. So let's go to our activity screen. All right, now here's the important thing that each of you will need to do if you haven't already. You should have gotten an email from Khan Academy. If not, look at this, starting the matrix unit. We're pulling this from Khan Academy. There are 2 links here. This is 5th hour, so you need to click on this link. I hope it got the whole length. I don't know. I may have to correct that. It doesn't look like this part is in the link. But you should have had an email, so you shouldn't have to click this link. You should have an email to join my Khan Academy class. There's a Khan class. You might need to copy this whole thing here and just paste it. But that is my Khan Academy class, so it will keep an update that you're getting your work in there. But that's what the starting the matrix unit is. And it says we're going to have 2 quizzes and then a unit test over matrices. We're just going to cover a little bit of matrices. You'll cover more in Algebra 3. But in Algebra 2, we're covering just some of this stuff. So under starting the matrix unit, make sure if you did not get an email, then you need to be clicking this to join my class in Khan Academy. All right. Now let's go look at what we're looking at this week. Week 24. I'm putting this in folders based on our week. I think this is week 24, right? Did I look at that right? Yeah, this is week 24. Okay, so week 24. Intro to matrices. When you open these folders, first thing we have is an intro to matrices video. We're going to watch this together in class, but you can rewatch it if you need to go back and review that. It's only like 4 minutes. And then we're going to look at the intro to matrices lesson, and we're going to look at the first assignment as well, because I want you to know how to do this. And you also have representing linear systems with equations with augmented matrices. So let's go to this intro to matrices video. Now notice this is a link, and it'll pop up in a separate window for you. But I'll pull this up. Intro to matrices. This is our lesson here.
What I want to do in this video is explore the notion of a matrix outside of the context of a surprisingly good movie that involves Keanu Reeves, and it's actually the first of 3. I guess we could call the 3 movies combined the Matrices. And there is a relationship between the movie, which is about a virtual reality constructed by super smart computers, and the relation and the notion of what a matrix is when you study it in mathematics or when you study it in computer science. And the connection really is that matrices are used a lot when you are simulating things or when you're constructing things in computer science, especially in, frankly, computer graphics. So the super intelligent robots that made the matrix in the movie Matrix were probably using matrices in order to do it, if they actually did exist. Now, what is a matrix then? Well, that's a fairly simple answer. It's just a rectangular array of numbers. So, for example, this right over here, if I have 1, 0, -7, pi, 5, and, I don't know, 11. This is a matrix. This is a matrix where 1, 0, -7, pi, each of those are an entry in the matrix. This matrix right over here has 2 rows, and it has three columns. And because it has 2 rows and 3 columns, people will often say that this is a 2 by 3 matrix. Whenever they say it's a something by something matrix, they're telling you that it has 2 rows, So you see the 2 rows right over there, and they're telling you that it has 3 columns. You see the 3 columns right over there. I could give you other examples of a matrix. So I could have a 1 by 1 matrix. So I could have the matrix 1. This right over here is a 1 by 1 matrix. It has 1 row, 1 column. I could have a matrix like this: 3, 7, and 17. What is this? Well, this has 1 row. This is the 1 row we see here, and it has 3 columns. This is a 1 by 3 matrix. I could have a matrix, and I think you see where all of this is going. Figuring out the dimensions of a matrix are not too difficult. I could have a matrix that looks like this, where it's 3, 5, 0, 0, -1, -7. This 7, -7. This right over here has 3 rows. So it's 3 rows, and it has 2 columns. So we would call this a 3 by 2. Let me do that in that same color. We would call it a 3 by 2 matrix. 3 rows and 2 columns. So fair enough. You know that a matrix is just a rectangular array of numbers. You can say what its dimensions are. You know that each of these numbers that take one of these positions, we just call those entries. But what are matrices good for? I still might not be clear what the connection is between this and this right over here. And at the most fundamental level, these are just ways, this is just a compact representation of a bunch of numbers. It's a way of representing information. They become very valuable in computer graphics because these numbers could represent the color intensity at a certain point. They could represent whether an object is there at a certain point. And as we develop an algebra around matrices, and when we talk about developing an algebra around matrices, we're going to talk about operations that we're going to perform on matrices that we would normally perform with numbers. So we're going to learn how, or we're going to essentially define how to multiply matrices, how to add matrices, how to we'll learn about taking an inverse of a matrix. And by coming up with an algebra of how we manipulate these things, it'll become very useful in the future when you're trying to write a computer graphics program, or you're trying to do an economic simulation or a probability simulation, to say, oh, I have this matrix that represents where different particles are in space, or I have this matrix that represents the state of some type of a game. And I know the algebra of matrices, and I know ways of doing it very efficiently so that I can multiply a bunch of them, or I could come run a simulation and I can actually come up with useful results. So that's all matrices are, but as you'll see through this, we can define operations on them. And then later on, when you take a linear algebra course in college, you'll learn a lot more of the depth of how they can be applied and what you can use them to represent.
All right. Did it bother anyone else that he misspelled columns? Anybody? Just wondering. It bothers me when people misspell things in public things like videos. Yeah, columns has an N after the M. It's M-N at the end. Anyway, that's the intro to matrices. So that's a video where we watched it together. You can go back and watch it again if you need to, but it's just showing what it is. So let's look at the next thing, the intro to matrices lesson. So let me put that up on the screen. All right, so when you click this intro to matrices lesson, it pops open this window. All right, so this is, the first one was the video explaining it. This is just in writing. So a matrix is a rectangular arrangement of numbers into rows and columns. Right, like this matrix A equals 2 rows, 3 columns. Right, so there's the MN, like that. So the dimensions tells the size of the matrix, the number of rows. In that order, the rows, then the columns. Since matrix A has 2 rows and 3 columns, we write it as a 2 by 3. All right, so now we're going to have a look there. This is where you put this in the chat, guys. Here you go. Here's a chance to see if you're getting this right off. Very basics. What are the dimensions of matrix D right here in the middle of the screen? Matrix D gives a place that I'm going to type these in here so we can check our work, but they got the checks right here where you can check your work. What are the dimensions of matrix D? Joy says it's a 4 by 3. Arabella agrees. Anybody else? All right, I'm seeing a few people putting some 4 by 3s up there. So let's test that out. I'm going to put 4 by 3. Check. Hey, it gave us a green check mark. Good job. All right, here's another one. Matrix E. What are those dimensions for matrix E? 2 by 4, 2 by 4. It's a piece of lumber. It's 2 by 4. Oh, wait, 2 by 4, 2 by 4. Oh, let's see. All right. I see 2s. I see 4s. Let's see if that's right. Yes, we got a check mark again. How about F? That's a little different. 3 by 1, 1 by 3. Oh, I'm seeing both. Yeah. 3 by 1. Well, let me show you what happens if we do put 1 by 3 and we hit check. Oh, it gives us a X. Remember, the rows are first. There's 3 rows, but there's only 1 column. So we can go back and change that to a 3 by 1. Now we get the green check mark. So it'll tell you if it's wrong with the red X there. So let's talk about what an element is, a matrix element. That's just one of the entries in the matrix. So we can name each element in there. So let's look at this matrix G, and it's a 3 by 3. We can see it's a 3 by 3. So if we have one that we call, and you can't hardly see that. Let me see if I can make that bigger. Man, when you do this on, I can close that. When you do this on your computer, you can make that bigger to see that too. But there you go. All right. Matrix dimensions. That was. Oh, now I gotta get back down where we were. Okay, can you see right here? It says the element, and then right after that has G 2, 1. 2, 1. So that means it's looking in matrix G for the second row and the first column. Second row, first column. So G21 is 18 because that is the element that is in the second row in the first column. So there, G21 equals 18. So in general, we can just say row I and column J. We could say A, I, J to represent any element. All right, so let's check our understanding again. If we have this matrix A, and we want to know A13, which element is A13? All right, I see 8. I see a few people saying 8. A13. So that would be first row. Rows go left to right. Third column. Yes, let's see. 8 should be right. 8. Yes, it gave us a little check mark over there. It's hard to see. I've kind of got it off the screen since I've blown it up so big. And look, if you need help, you can click that and it'll pop up, tell you how to do that. A13 is the first row in the third column. In this case, A13. So you got little helpers for you there. All right, let's look at this. B21. B21. Joy says 4.6. 4.6. 2, 1. Second row. Yeah. Jonathan got 2-2 there. He jumped quickly. Second row, first column. 4.6. Yep, little green check mark. All right. If matrix C is a 2 by 3, that C12 equals 6. All right, and wants to know which one of these could it be. So let me make this a little smaller so we can see more of them on the screen. I'll close that again. All right, so if it's a 2 by 3 matrix and C12 is 6, which one of these could it be? A, B, C, or D? Jonathan says it could be B. It's a 2 by 3 matrix. That's important. And C12. Oh, Jonathan's changing his answer. C12 is 6. He said it's C now. Ty says B. Joy says it's C. We got B's and C's here. B's and C's. Well, the good thing is C12 is 6 and 6. That's correct. Either one of those. C12 is in the right position on B and C. But only one of those is a 2 by 3 matrix. The other one's a 3 by 2. So remember, the rows are first. So the 2 is the number of rows it has, and the 3 is columns. So this has 1, 2, 3 rows. So this is a 3 by 2, not a 2 by 3. So it is C. So we click C, check. Yes, that is the correct one. All right, and then it's got where you can ask questions if you have questions on there. So that is all of that lesson. Let me back off there a little bit. All right, so when you get to the end of that, that's great. Close that window, go back to Buzz. Now let's look at the next thing we have. All right, here's an actual assignment. And it says, take a screenshot of your score at the end of the assignment. Then scroll down and paste that into this box. Okay, so let's click the link below and view the content. And then so let's click on matrix dimensions. Now notice when you get here, it says eventually, and again, we can close this if we want to get this out of the way. Ready to practice. There's going to be 4 questions. Now this said that we need to take a screenshot of our score at the end. Score at the end. We haven't taken it yet. This is a start. We've got to click this little let's go button down here at the bottom. Let's go. All right, here's our first question. What are the dimensions of this matrix? So we can kind of do this together. You may have different questions when you do this on your own. They kind of randomize at Khan Academy. But this one, what are the dimensions of this one? Joy says it's 2 rows and 5 columns. 2 by 5. 2, 5. Yeah, let's just check down here. Check. Oh, good work. You got it. Onward. All right, next question. Notice I put a little check mark there at the first question. So we're on question 2. What are the dimensions of this matrix? There's a lot of numbers there. Oh, I'm seeing a bunch of people with 5 rows, 4 columns. 5 by 4. 5 by 4. Check. Nice work. Keep going. Or they give you the option to see how we answered it. So if you just guessed and wasn't sure how you did it, or you can click here and see a step-by-step solution. So they do give you help if you just guessed and like, oh, I got lucky. Well, maybe you should see the step-by-step solution. Say they mention the first dimension is the number of rows, and there's 5. Second one is the number of columns, and there's 4. So it's a 5 by 4. Next question. What are the dimensions of the matrix? You guys got this. You're getting good. 4 rows, 3 columns. I see 4 to 3. Hit check. Good work. You got it. Onward. Last question. What are the dimensions of this matrix? Trying to get tricky on you. You won't be fooled, will you? Right, how many rows are there? Rows go first. Rows go first. There's only 1 row. And there are 1, 2, 3, 4, 5 columns. 1 by 5. Check. Show summary. All right, this is what I want to take a screenshot of. Because it told me to take a screenshot. So if I go here and say, okay, I'm taking a screenshot. Look, it's got my, can't hardly see it up there. It says Mr. Brock up there in the corner. If I take that and I go back to here, scroll down, and I pasted that into Buzz. And it shows that I got 4 out of 4 correct, and I submit my work. Okay, I can resubmit. If I went back and said, oh, I only got 1 out of 4, maybe I would have clicked and do this again. So I close that. I can click this and do it again. It'll take me back and let me do it again. It's like, I know I can do better than 1 out of 4. And you can go back and redo it. See, 4 questions. Let's go. So you can go back and redo it if you didn't do well and submit right there. All right. So that's what this unit looks like. Look, we made it all the way to matrix dimensions. There's the matrix elements assignment. That's what we looked at second, like A 2, 1. Okay, that's the assignment there. That's another one where you do the 4 problems, take a screenshot, paste it into Buzz. Then we have another lesson here representing linear systems of equations with augmented matrices. So again, you click on that, it's going to take you to a video. Oh, no, this is not a video. This is just the lesson in words. So let's look at this. A matrix is a rectangular arrangement. We already know that, of rows and columns. But we can represent a linear system with matrices. So let's look at this. Let me close this and make this a little bigger on the screen. All right, so if we have a systems of equations, we got 2x plus 5y equals 10. And we have another equation that says 3x plus 4y equals 24. We can take just the numbers, just the coefficients, and make a matrix out of it. 2, 5, and 10. That's the first equation, equation 1. 2, 5, and 10. 3, 4, and 24. We take the 3x and the 4y and the 24. And this is the x column, the y column, and the constants. Equation 1. So this is how we take a linear system of equations and convert it into a matrix. So in an augmented matrix, each row represents one equation. See, the first row up here is the first equation. The 2x plus 5y equals 10. 2x plus 5y equals 10. And each column represents one of the variables or the constants that it equals. So we can see the augmented matrices are a shorthand way of writing systems equations. That's just kind of shorthand, taking shortcuts. See, it makes it unnecessary to write x, y, and equals because we can see, okay, well, this is the x column. So these are the x's, these are the y's. All right, so check your understanding. Which matrix represents the system? Let me make this a little smaller again so we can see more of it at the same time. Oh, there you go. There's just 2 choices. If we have 2x plus 3y equals 8 and 5x plus 2y equals 2, does A represent that or does B represent that? Oh, you guys are saying B. See a couple of people on it. Anyone agree with that? Let's see. The first row is the same. 2, 3, 8, 2, 3, 8. And that's 2, 3, 8. So that doesn't help you. But the second row is 2, 5, 2 or 5, 2, 2. Well, this is a 5 for the x. The x is the first column. It's got to be B. Yay, good job, good job. Let's look at this. This one, they want us to write the following system equation as an augmented matrix. All right, so what's the first row going to be then? If we have to write this system of equations as a matrix, so the first row should be 7, 4. Joy's on top of this. She's already got it. 3. And then we should have 6, 3, 5. Check. Good job. Let's see. Do they give us another? Oh, this is a really good one. Let's look at this a little more complicated. So if we wrote this as a system of equations, now we have 3 rows. And looks like we're going to have more columns. Look, we've got a 3x and a minus 2y equals 4. But then we have an x and a 5z equals negative 3. And then we have a negative 4x and a y, negative y, and a 3z and a 0. So before we look at their solution, what would the first row be? What do you think? The first row. This is a little trickier because we when we look at all of the system, we've got a 3x and negative 2y equals 4, but then we've got an x plus 5z equals negative 3. Then we got an x, y, and z in the last one. This is a little trickier because remember what these represent. Remember what they represent. This is the x column. This is the y column. This is the constant. So now we've added more. We still need an X column. We still need a Y column, but now we need a Z column and a constant. All right, so does that change your answer on anyone that's answered? We're going to have an X column, a Y column, a Z column, and a constant. So that first row, let's look down at the first row. The first row, we got a 3, a -2, 0, and then 4. There's 0 Z's. This one doesn't have any Y's. So the second one, if we rewrote those to put in those X and Y's that are missing, the Y's and Z's, this is what our matrix is going to look like. 3, -2, 0, and 4. 1, 0, 5, and -3, because we just had X plus 5Z. X plus 5Z equals -3. So X, skip the Y's, plus 5Z's equals -3. And then -4, -1, 3, and 0. So there's the tricky part, is if we're missing an X or a Y or Z, we still have to account for that when we turn it into a matrix. Because this column can only have X's in it. This column can only have Y's in it. And we have to have the same number of columns in every row. We can't have a row that has 3 and another row that has 4 columns. You have to put in the zeros. All right, because it's always rectangular. It's always rectangular. It's not a weird shape. It always has to have the same number of rows, same number of columns. All right, so let's see which one of those would represent this system. 3y minus 2x plus y plus 5z equals 10. Now notice the first is the same. 3, -2, 1, 5, 10. 3, -2, 1, 5, 10. The first row is the same in either choice. But the second one, w plus 2y minus 4z equals 5. Is that 1, 0, 2, -4, 5 or 0, 1, 2, -4, 5? What's missing? Which variable is missing in this equation? And they go in order. W, there's both of them have a W. X, this one does not have an X. So which matrix has a 0 for X? Let's see. You guys are saying B. Let me check B. No, because this is the W column. Because the 3 is a W column, so the 1 has to go in the same column as the 3. See, the 1 has to be in the same column as the 3 because that's the W column. This is the X column. -2 is the X column. So notice there is no X in the second one, so there's a 0 over there. So we'll hit. Oh, I didn't. It didn't have me check it. There we go. Yeah. So remember, these matrices columns represent a variable. This represents W's. This represents X's. This represents Y's. This represents Z's. So those numbers should match up with the coefficient. 5 and -4 is the Z's. The constants out here, 10 and 5. So yeah, be careful. Look at the variables and know which column is missing. There's no X. So -2 is another one, but 0 is in the other one. So with it. So all right, so now it wants to write this one. Oh, this is a good one. All right, so what's our first row going to be? We got -a plus b minus 2c equals 12. What is our first row going to be for our matrix? And then we'll write the second row here in a moment. But let's get the first row first. The second row just has an A and a B, if that helps. We do need to look at the second one because if it had a D, that would change what we're doing. First row, -a plus b minus 2c equals 12. What numbers are we putting in here? Okay, so Bethany says, let's put a -1. So -1. And then she said, put a +1. and then put a -2, and then put a 12. Everyone like that? Anyone want to change anything there? Okay, if we like that one, then what is the second row going to be for our matrix? Okay, Arabella gave it a shot. She said, is it 3 and then 1 and then 0 and then -8? Everyone like that? You want to try something different? So it says 3. This is the A column, right? A, -1, 3. Great. The B column, they both have a coefficient of 1. There's 1B there, 1B there. The C column, -2 C's. Oh, there's no C's. So it does have a 0 and then the 12 and -8. So we should be right. Good job, guys. So they get a little bit more complicated, but it's just a matter of matching up all the variables. Make sure you got the X's together, the Y's together, the Z's, the A's, the B's, the C's, whatever the variables they are. Oh, challenge problems. All right. Okay. Oh, they're doing it backwards now. So they gave us the matrix, and we have to choose the system of equations. Oh, this is good. All right. So looking at the 820, that's the same in both of them. They both have 820 on the right. So the problem is over here. What letter, what variable is represented by the first column? What variable is by the second column, which one's by the third column? And how does it match up? So Arabella says it's B. That's her choice. I'm going to click it right now. That's her choice so far. Unless anyone disagrees. Or does anyone agree? Do we have confirmation? Or do we need to change? So what's the difference in them? Let's see. The last row, 5x plus 2y minus z, that's the same. The second row, 4x plus y plus z, 4x plus y plus, that's the same. So the only difference is in the first row. Is it -3x minus 5y, or is it -3y minus 5z? Well, the 0 is up here in the very first one. That is apparently x, y, z. X, y, z. There's no x. So it should be the second one. And that's absolutely correct. Good job, Arabella. All right. Oh, now they gave us 4 choices. Which matrix represents this system? So 3x plus 2 equals 12y. Oh, look, they've rearranged things. -8y equals 2x plus 15. This is a challenge problem. Okay, Bethany thinks it's B. Let's do this. Okay, I wrote this one down. And we've got all kinds of stuff. But we know when we had the matrix, all the constants were on the right side, right? We got to put things in the right order. These are not in the right order. So let's take this first one and rewrite it. 3x plus 2 equals 12y. Let's move the 2 to the right. 3x equals 12y minus 2. And let's move the y minus 12y minus 12y. Okay, x comes before y, so 3x minus 12y equals -2. Okay, this is in the right order for a matrix. X, then y, then the constant. Okay, so we can do that. 3x minus 12y equals -2. Okay, now let's get this one in shape. So we got -8y equals 2x plus 15. Looks like all we need to do is move the x over. So it'd be -2x minus 8y equals 15. That was the only thing out of place. The x was on the wrong side. So this would be -2x minus 8y equals 15. So what would that look like as a matrix? We just take the coefficients. It'd be 3, negative 12, negative 2, negative 2, negative 8, 15. Right? For the matrix, we just get rid of the x's and y's, and we just keep the coefficients. 3, negative 12, negative 2, negative 2, negative 8, 15. Let's see. 3, negative 12, negative 2, negative 2, negative 8. It looks like it's this one. See, that's why we have to rearrange them, because when we look at it, we see that's a positive 12y. But we have to put them in this order. So it becomes a negative. That 2 becomes a negative when we move it over. We have to have these in the same sequence. X, Y, constant. X, Y, constant. So while they have the right numbers, like here on B, it didn't change those. It didn't move those to the other side of the equal sign. So that's why you have to really rearrange this on paper first. And don't just look at the numbers they used, because using the numbers that they used is not going to turn out right. C, let's check our work. Correct. So yeah, so you need to go through that process and rearrange them to where they're in the proper order. X, Y, constant, or X, Y, Z, constant, or A, B, constant, whatever it is. All right, that was a good problem to have there. And that's the end. That's the end of that one. So, and then the last thing you'd have is another assignment there where you take the screenshot again. So I'll give you 4 more problems to practice. Paste your score in there. And that is the end of the week. Right? That's all we're doing this week is learning about matrices, rows and columns, learning about the elements, like if we're talking about A2, 1, which element are we talking about? And then how do we represent a linear system with those matrix equations? So, all right. You've got the videos and the lessons right there. You can go back and watch those anytime you need to. Screenshot your score in there. It's just 10 points for each one. If you don't do well, go back and redo it and paste a good score in there, right? Because it'll let you go back and redo that. Just click on it again. But make sure that you join my class. You should have an email from Khan Academy, I think last week, Thursday or Friday. So make sure that you join it. If not, it does have the link here. Again, you might have to copy and paste that whole thing. But that's how you join the class if you didn't get the email. But you should be in my class, is to go to that starting the matrix unit thing and get that going. So, all right. And some of you have already worked on that. And Bethany wants to know how the bowling tournament went. I thank you for asking, Bethany. Actually, we had one of our girls made All-State. So that was a big success last week. We went to Cabot and made All-State with one of the girls, which is great. I coached the Bentonville West team. So we went with BHS. BHS did not have an all-stater this year. Usually BHS brings home some trophies and stuff, but they kind of have a down year. But I'm very happy with our bowler. Sophia, if anyone knows her, Osario Bonella is her last name over at West. Sophia made all-state this year. So I was very happy for her, very excited. But yes, thanks for asking. So, all right, guys, that's all I got for you this week. We'll be doing this for the next couple of weeks. So hopefully this goes quickly for you. The Khan Academy really makes it clear. Those videos just lay it right out for you. So if you have any trouble, this is a B day. So if your grade's below 70, go get that stuff turned in. Get your grade up. You don't have to be here. We have 3 B days this week and 1 A day. Tomorrow's your only A day. But we got a B day Thursday and Friday. So if your grade's below 70, I'll see you Thursday and Friday. Or if you need help, come on by. I'll be in class. But otherwise, have a great week, guys. Go and have a great Valentine's Day tomorrow.